You stand by. All right. Good morning, you guys. Can everybody hear me? Can you hear me up back there? All right. So my name is Van Macomb. I met Jim at the SAM show. He invited me to come present. That is my table out there, the Nonskid. That's the samples I brought for you guys to take a look at. So I'm calling this succinct rubber particles for Nonskid. Do we have a paradigm shift relative to what's currently being used in the industry, which is mainly mineral aggregates and things like that. So, whoops, I'll get into that in just a little bit here. But first, let me walk you through what is soft sand rubber. So it is, first of all, it's not a scrap rubber material. Everybody thinks it's some kind of scrap rubber. It's not. It's actually a vulcanized rubber compound that we cryogenically grind to get the different particle sizes that you see on the table out there. We developed it about 20 years ago, and it was formulated specifically to solve a problem with polyurethane coatings in the construction industry. And in particular, what you see here is a condominium complex, and that upper deck where these cars are parked is actually, there's a parking below that. So this structure is a roof structure, and it's also a parking surface. So it has to be waterproof, and it has to be non-skid. So this particular company was having a problem with aggregate and was actively searching for a solution to the problem of aggregate coming loose in the coating. So they had tried all the minerals, black beauty, silica, sand, and whatnot. They'd even tried a lot of scrap rubber materials, which it's getting closer to a solution, but a lot of the scrap material is a different polymer system. So a friend of mine is actually a rubber chemist. I'm an engineer by training. And the two of us sat and looked at this problem and said, what you have with this aggregate coming out of the coating, which results in a loss of your non-skid, the solution to that is going to require two things. First of all, you have to have good adhesion between the particle and the coating, right? That's step number one to making a good composite structure, which is how we view non-skid coatings. And then the second thing, you have to have a modulus match between the coating and the particle. You can have a rigid matrix like an epoxy or a concrete, and you use a rigid particle or aggregate. If you're using polyurethane coatings, which is what most of these guys are using on their boats today, it really calls for a flexible elastomeric particle. So that's the way we formulated this problem. And these next few slides, I'm just going to show you how we sort of prove this out over time with this particular coating system. So this is just a close-up of that parking deck I showed you earlier. What we decided to do on this deck was use, it's a nice small deck, so it's a nice little test area. We used both the sand aggregate that they had been using over the years, and we also used the soft sand. In this case, we used white soft sand particles, so we'd have a contrast over the gray coating. And you guys can obviously see where I'm going. I view a deck's a deck, whether it's a concrete deck or a steel deck. The coatings are very, very similar. So this is the history where we got started. So I went back 6 years later and took a look at this. So again, it's the white particles you see there is where is exposed with the soft sand after 6 years of traffic on this deck. All those little craters are where the sand aggregate had been and was ejected from the coating over time. So this is a nice little test case that we did up in Connecticut. There should be a little piece of sand on Roosevelt's temple on the dime there. Like I said, black craters are where the sand particles had been, and the white dots you see there are the tops of the soft sand rubber particles. When you go and inspect a deck like this, here you have a steel grate, and then you've got the concrete deck, and you have a change in elevation between those two surfaces. So when you go out there, this is going to be a high impact area. It's be one of the first areas you'll inspect to see what the wear is. And you can see, hopefully you guys can see, again, all the craters are where the sand particles were ejected. The white dots are where the polyurethane coating has worn off, exposed the particles, but they're still embedded in the coating. So that's a high impact area. You know, right here coming off this grate, you're gonna see here, right? So come off the grate, the tire is gonna hit that, and it's gonna knock the particles out that much faster. What does that mean? This guy actually spun his tires on the deck, so you can see the black tire marks. And again, the white rubber particles are still firmly embedded in the coating. So it's just a nice little spot to accentuate the point I'm trying to make about the rubber stays bonded. All right, so back to my original question, you guys, proposition, you guys, is it a paradigm shift? And I kind of came across this idea from reading some of the data sheets that the big paint companies put out when they used to make more specific recommendations about what to do for non-skid. And if you're using black beauty or aluminum oxide or some other aggregate like that, I think the concept, everyone understands that an abrasive material is going to be tough on equipment. It's going to be tough on your skin if you fall down. It's tough on your ropes and whatnot. So the practice that's evolved over the years with that understanding is that if you read some of these data sheets, they recommend using as little as possible to create a non-skid surface. I've seen some recommendations as light as 3 ounces per gallon of paint, which is, you know, not very much. And if you look at the particle size they recommend, it's often, you know, 60, 80, 100 mesh. It's a very fine particle. So to me, the practice with that in mind is use as little as possible if you're going to use an aggregate to create a non-skid surface. That's sort of the mindset that's evolved over time, as I see it, when you're using mineral for non-skid. So contrast that with the concept when you have a rubber particle like saw sand is, number one, rubber particle is not going to cut you up, right? It's going to feel better on your bare feet. So now you have a practice with saw sand that we're seeing, and especially with the on the pleasure boating side, you're seeing a full broadcast where they're actually putting 100% down of the rubber particles. And then you put a, you know, top coat over that. But it's a totally different approach to using, you know, 3 ounces per gallon. Now you're fully saturating the surface with rubber particles. And in general, the boaters are gravitating towards a much larger particle. If you look at the samples I have out there, the medium grade is probably, you know, it's quite a bit larger than what you're seeing with some of the plastic granules. And then the one out there is, we actually have a 1/4 inch rubber particle that we're putting down on some work boats, like some lobster boats up in Maine and things like that. So I think it's a very different approach when you have a granule that's more compatible with your coating and your bare feet. So another way to look at this in terms of non-skidded additives, generation 1, generation 2, and 3. The commercial industry is really heavily still, I think, within generation 1. I see black beauty everywhere on a lot of the work boats out there, and some silica, some pumice, and some aluminum oxide. All right, so generation 2, I would say in pleasure boating, most of the paint companies, at least in the US, virtually all of them have gone to either a polyethylene or polypropylene bead. And some of them will tell you it's a polyethylene, it's a low molecular weight polyethylene, which essentially is a wax. So from a modular standpoint, from a comfort standpoint, it's a step in the right direction because you're getting away from the, you know, the tough blast aggregates. But we really feel that the best solution with a elastomeric coating is going to be an elastomeric particle, which is what saw sand was developed for. And then the another consideration, this is brought to my attention by someone, OSHA has again reduced the permissible exposure level for crystalline silica. It's down to 50 micrograms. I think that's an order of magnitude less, which is 50 millionths of a gram, I believe, per cubic meter. So they're cracking down on, from a regulatory standpoint, on the use of minerals. If you look at some of the data sheets for, you know, aluminum oxide, black beauty, you'll see some tell you what the content is, or they'll say something like less than 1%. How that translates into what's respirable is, I don't know, but point is, you know, OSHA is taking a look at exposure to some of the materials. And you're supposed to actually start measuring it if you hit 25 micrograms per cubic meter. This was a exhibit at the Workboat Show past couple of years, and this is on this in Savannah, Georgia. This was my backdrop. So this was a nice testimonial. This company, Merrick Marine, started using the rubber particles. It was a nice testimony. We had 0 slippage problems since we started using soft sand rubber particles on our decks. They're in process of doing all the barges and all the boats converting over to soft sand from Black Beauty. And that was nice. These, you know, these spuds are used to anchor the barge. So he said he picked the 10-ton spud off the deck, and there's no crushing of the aggregate, so he couldn't tell where it had been. So it's a nice little testimonial that I use for the Workboat Show. Okay, that's all I have today. Any questions? Anyone take a look at my samples? Or if you guys do get into Nonskid and you have customers that want to evaluate samples, just let me know. We have a pretty active sampling program to, you know, for your customers or for yourself. We're happy to support that. Sure. Good question. We are just the aggregate, so it's easier to get these guys. You know, you have painters that like certain systems, you know, certain coatings from certain manufacturers. They figured out how to use them. So all it is changing out the aggregate. And you can use it the same way. You can broadcast it by hand, or you can mix it in, spray it, mix it in, roll it, that kind of thing. So it's just it's an aggregate substitution, basically. Yeah, good question. Anyone else? Okay. Great.